Thanks, EB. So welcome everyone. We just moved into this building, like about 2 months ago. So Kalitha and I and Brian and Alni, we're all excited to really host the meetup here and welcome, so many of you, some old friends and some hopefully future friends into our current home. I'll just speak for a few minutes today. What I want to do is tell you a little bit about some of the trends in deep learning that I find exciting, and allude just a little bit to some of the work that we're doing here in Baidu. I'll leave Brian and Alni to carry the heavy lifting of telling you about most of the work we're actually doing here. Um, and by the way, what is that beeping? Oh, okay, great. All right, thank you. All right. All right. Okay, all right. Great. Good to know. Thank you. Um, and then, so want to talk a little bit about trends in deep learning that I find exciting that might be helpful to some of you as well that are thinking about how to develop your own deep learning, research agendas or apply these ideas. And I'll tell a little bit about some of the trends in China that I find exciting because I think here at Baidu we have a unique opportunity to develop technology to help a lot of people that could use the help of technology. So I'm excited about that as well. So as many of you know, deep learning on neural networks has been taking off like crazy for the last few years, right? Frankly, somewhat overhyped in some places. And all deep learning is neural networks like these, where you input some data, maybe a picture, and you have a neural network try to recognize this object, right? Is this a coffee mug or not? Um, Even though there's been a lot of hype about deep learning, in my opinion, almost all the value of deep learning today is created just by supervised learning, meaning learning simple input-output pairs, right? And so for supervised learning, we have a lot of data, a lot of images, together with labels of, is this a coffee mug or not? And I think that what's really caused deep learning to rise, cutting through the hype, if you were to run PCA and look at the first principle components or something, right? Um, I think the main reason for the rise of deep learning is scale. And this is actually not a popular opinion, but it's the one that I believe to be true. So when talking about deep learning, I often like to make an analogy to building space rockets. So what is a space rocket? A space rocket is just a huge engine together with a ton of fuel, right? And you need both to be large. If you have a huge rocket engine with a tiny amount of fuel, well, that's not going to work. You're not going to get to orbit. If you have a tiny little engine and a ton of fuel, well, that's also not going to work. It probably won't lift off. But the only way to get to space is with a giant engine and a lot of fuel. So the analogy to deep learning is that the large rocket engines are huge neural networks that we're now finally able to build, thanks to, the work with GPUs, distributed computing, and I guess actually some of you, I don't know if Brian likes to say this. Brian, who will speak later, was the creator of cuDNN. So for any of you that use deep learning on GPUs, and he was the one that led the work at NVIDIA, led machine learning strategy at NVIDIA for quite some time. So many of you that are doing deep learning on GPUs are building on the foundations I think Brian had helped build. You hear from Brian a little bit. But so this type of work is allowing us to build bigger and bigger rocket engines. And complementing that is the huge data sets that we now have access to, right? That we can feed to these huge rocket engines in order to build very accurate classification and so on systems. So a lot of the progress, I think with the world moving to the internet, with the rise of the internet, with the rise of digital devices, we started to have more and more data. And what really made deep learning work over the last, I want to say 5 years, is a rise in scale, just bigger and bigger rocket engines. Many years ago, most of us used to do our deep learning on normal computers, CPUs, so relatively small neural networks. A few students and I at Stanford, started publishing papers, and Brian at NVIDIA is working on this as well, to try to suggest that people move on to GPUs, which was a controversial thing back then. Now it's pretty obvious. Then some friends and I, started to work on cloud computing techniques. I did some of this at Google, which helped us build even bigger models. And then most recently, Adam Coates, Brian Catanzaro, and a few others started, really led the way to building HPC or supercomputers. HPC stands for high performance computing. And I think this is letting us, drive the next level of scale. And I think that the scale provides a foundation that makes machine learning researchers more productive. And that's what I guess I've been focused on for a lot of my career, even before Baidu. But I think at Baidu, we're hoping to build, an amazing platform to enable researchers to be really productive and to scale up our deep learning algorithms. You'll see a little bit more about that later. So I think that in the past several years, the first trend for deep learning was just scale, right? And this is an unpopular opinion because when we go to academic conferences, we like to talk about the cool new algorithmic ideas and so on. And that's definitely been important. But I think that scale is really the thing that's been underpinning all of the algorithmic work. Beyond that, I think there's one other trend that I've been excited about that we've been seeing just in the last year or so, which is outputs that go beyond classification. So here's a concrete example. If I show you these pictures and ask you to describe these pictures, you can write captions like these, right? Like, yellow bus driving down the road, green trees, green grass, or living room, blah, blah, room in the apartment. I don't know what's going on. All right. I see. All right. And here says, room in the apartment, get some afternoon sun. So, not sure if any of you guys have seen these results before, but if not, I have a surprise for you. These captions weren't written by a human, they were written by a computer. Right, so about a year ago, actually no, less than a year ago, we collaborating with UCLA were the first to demonstrate that you can have a deep learning algorithm input an image and output a caption. It was very surprising to me, to a lot of us, that we could actually get this to work. And since we published this result, a lot of other teams have been following us and developing similar results. This is really weird. Do you think so? Can people hear me if I shout like this? Yeah. All right. Let's try this for a while and see if this works. Okay. So let me take a little bit into technical details to share with you how we actually do this. At the most abstract level is this supervised learning again, input-output mappings. We show the algorithm a lot of pairs of images together with captions. What does this actually mean? Here's how we actually train this neural network. What we do is we first train a simple object classification algorithm to take as input an image and recognize the object. Right? So simple image classification. Once you've done that, we found that the penultimate layer in the neural network learns a pretty good representation for the input image. What we do then is use multitask learning, where we look at the learned representation, and we then have that representation try to generate the caption. And the way the caption is generated is actually with a recurrent neural network, with RNN, that generates one word at a time. So once we develop this architecture, I guess us and others kind of working in parallel have been developing these types of architectures that are now able to output complex structures. So rather than outputting a single label, just in the last year or so, we and other teams have started to develop algorithms that have complex structured outputs, such as sentences. So I think this is maybe the one big trend I've been seeing in the past year or so that I find very exciting for deep learning, and I hope will continue to pick up. In the AI lab here, this particular piece of work was done by the Institute of Deep Learning, which is part of Baidu Research. In the AI lab here, something you hear Auni talk about a little bit is speech recognition, where instead of very complex pipelines, which is what used to be done, we instead have a neural network input an audio clip and output the transcript. And I think this is allowing us to transform the way that speech recognition is done today. And I think is very promising for making speech recognition work much better for all of us. So Auni will give you the details of this in a little bit. Before I wrap up and pass it on to Brian and Auni, I want to share you a little bit about the trends I'm seeing in China and why I'm excited to do a lot of this work at Baidu. First is that China, more so than the US, is very much a mobile-first society. Most of us in this room had probably first had a desktop or a laptop and then got our first mobile device. Most users in China, actually only have a smartphone and might not even have a laptop or a desktop. And this is a challenge and an opportunity. It gives us an opportunity to train them to new behaviors that make sense for a cell phone, rather than most of us, which are slowly migrating our behaviors from what makes sense on the laptop to what makes sense on a smartphone. And in particular, one of the really painful things about using cell phones is that no one's figured out a good input device yet, right? And it turns out that typing in Chinese is even more painful than typing in English. The Chinese writing system called Pinyin changed fairly recently, was introduced fairly recently, a new way of typing on these keyboards. And so there are huge groups of people, especially older 50 and 60 in China, that just do not know how to type on a modern keyboard interface on a cell phone. And we think that letting them use speech will be a much more convenient way to give them access information on the internet. And I think just on my cell phone, rather than typing text messages to my wife, right, saying whatever, I'm having dinner with a meetup, so I can't see you tonight. I'd rather just speak to my cell phone and have it send, and there's a much more convenient UI. So I think speech will be the UI of the future for mobile devices. So that's one reason I'm excited about speech. There's a second megatrend that I'm seeing in China that most people in the US have probably not heard of, which is online to offline. I'm curious, how many of you have heard of the term online to offline, previous to this slide? Yeah. Oh, wow. Actually, that's actually more of you than I was expecting. But this is a trend that all the large tech companies in China are trying to build. What I found was that, living in the US, my friends would try to tell me about O2O, online to offline, and I listened to them, and then I didn't get it. And then I read the analyst reports, the dry statistics by the financial analysts or whatever, and the reports were interesting. I still didn't get it. And what it took for me to understand this online to offline concept was when I finally spent time in China and started using more O2O apps. And then I was like, wow, this is different. So in order to try to explain to all my friends in the US what O2O is, I was just in Beijing last week, and I decided to shoot some videos with my cell phone of me using O2O apps because I thought maybe seeing it is the only way for me to explain what this third megatrend is. So when you want to wash your car, actually, how many of you go to Lozano's car wash? No, almost none of you. Where do you guys get your cars washed? Oh, you wash? I'm ready. Where? Oh, Valcron. Where else do you guys go? Shell. Oh, okay, cool. All right. So when I want to wash my car, it takes me about 20 minutes to drive to what's that called? Lazar, right, on El Camino. Then you stand in line to pay, stand in line to wait for the car to go through the thing, right? There's a nice barbecue thing, so you can eat some barbecue, which is nice. But then you drive home. So it takes me basically an hour to wash my car, which frankly is why I don't do it very often. So what I want to do in China was try out an O2O app for washing cars. O2O, online to offline, is transforming the world in which your cell phone is increasingly not just a communications device, but your cell phone is increasingly a remote control for the physical environment around you. So increasingly, by pressing buttons on your cell phone, you can get stuff to happen in the physical environment around you. So what I want to do is, so I have two cell phones. This is a Xiaomi cell phone that I use when I'm in China. This is my iPhone that I use in the US. So the way I shot this video was I set my Xiaomi phone on my table, and then I used my iPhone, this iPhone in fact, to shoot this video, which I'm showing you. This is the first time I'm showing this video to anyone, and it's totally unedited. So we said it takes me about an hour to order a car, to get my car washed here in the United States, right? I want you guys to take out your cell phones and start up your timer app. Right, take out your cell phone and start up your clock app. Right, your stopwatch app. And I want all of you to time how long it takes me to buy a car wash in China. Right. So what I did was one of my friends works on a self-driving car team at Baidu in Beijing. His car is really dirty because he's often driving to this kind of off-road place. So his car was mud splattered. So I don't have a car in Beijing, but I said, hey, Li Bo, why don't you let me buy you a car wash, right? And so I said, park a car here, I'll buy you a car wash just so I could make this video, okay? And I actually paid for his car wash, but you see in a second how much money I actually paid. So please start your stopwatches, okay? Go. So this is me on my Xiaomi cell phone. I'll mute this and just narrate this. So I'm gonna start up the app called eCar Wash. I should start my own timer too. And I'm gonna click the button on the left, which says come wash my car. There's a map. Oh, and I cheated a bit. I entered in his license plate number and car model in advance. Then I have to drag the map so that the little pin indicates the parking lot where he had parked his car. And then it costs 25 RMB, so it's about $4 US. I hit confirm. It pops up the payment thing. I choose Baidu Wallet. Yeah, I know. I hesitated. That's actually me. That was me entering my row pin number. Not very good hygiene. And this is a confirmation page, and you see a text message pop up in a second on top, I think, which is a confirmation code. There. That's a text message confirming they're on the way. So stop your stopwatch. How long did it take? About 1 minute. 1 minute. Yeah, cool. Right. So that's all I did. And about 2 hours later, Li Bo and I went down to his car in the parking lot, and the car was totally clean, right? And honestly, if it took me 1 minute to buy a car wash, I would do it much more often, right? Than now, which is almost never, I guess. And funny story. So how much did I pay for this car wash? Usually it's 25 RMB, which is about $4 or $5 US. Because this was on discount, I paid 1 cent RMB, which is about 1/6 of a US cent. So this is a really cheap car wash, but only because it was on promotion. O2O in China is letting people buy car washes in a minute. It turns out that this is pervasive. If you want food delivered, again, a few buttons on your cell phone. And yes, here we have DoorDash. My wife and I sometimes use DoorDash. But what really happens is my wife and I go to the DoorDash website, we click through, we look at the prices, and half the time we go, well, it's kind of expensive, let's just cook, right? You don't really get O2O until it's 9 p.m. in China, and one of these services delivers food to you in 20 minutes rather than, actually it's 25 minutes the last time I used it, rather than an hour, which is what DoorDash usually takes in the US. And man, when you're hungry, there's a big difference between 26 minutes and an hour. And the thing that's powering all this is technology, actually. The food delivery, China has the benefit of very high population density. When everything's closer together, it's easier to just make all these physical services work. But also what powers this is logistics. It's this delivery, routing car wash people around. With your cell phone, you can get someone to come to your house and give you a haircut, right? Or give you a manicure, or give you a massage. All of these. Or if you want a chef, you can actually order a human chef via your cell phone who come to your house and cook for you pretty cheaply. And if you want your clothes washed, with a few buttons on your cell phone, someone will come pick up your laundry and do it for you. And they charge $1.50 per shirt, right? So all of these things, China has the advantage of very high population density, and that's enabling it to have a platform to develop the technology. Having said this, I think 1 minute is too long. I think it's not good enough. What I want is to pick up my cell phone and say, please wash my car. I parked it in the parking lot outside this building. So that'd be 5 seconds maybe, and I think if you want to get there, the thing we need to solve is speech. I mean, I guess if I have an EA, she doesn't order my car washes for me, but right, if we all had personal assistants, it would take you 5 seconds to get the car wash. And if you want that, I think it's got to be speech, not the incredibly slow and painful 1 minute it took us just now. Right?
Why can't you just have your car go wash yourself in the morning?
Oh yeah, okay, yeah.
That's ideal.
Yeah, that's not a solution.
Or take a
Let's see.
Things that the car of death is the captive.
See. Wait, take a picture of the car and then what? All right. I see. Yeah. All right. Good. We'll work on doing this in 5 seconds. You work on it doing 1 second. Cool. So I think that's all I want to say. I think I've been in Baidu for a little bit, for like about 5 quarters now, for a little bit over a year. We've been growing this team rapidly and building up our systems team, building up a speech recognition team, but just very excited about the potential to build up, speech, images, start to look at healthcare technology using deep learning, but to build up all of these things using HPC, which Brian will tell you about, and speech, which Auni will tell you about, and trying to ship these things to hopefully hundreds of millions of users in the near future. So with that, let me hand it over to these guys, so they'll dive into the technical meat of this presentation. Thank you.